Let's start by looking at common analytics challenges faced by you, the data analyst. Data analysts, data engineers, and data scientists all analyze data sets to gain insights. However, they have different roles. Data analysts primarily gather and interpret data to solve problems and help companies make decisions. They use SQL and static modeling techniques to summarize data, build reports and visualizations, and derive insights. Data engineers build systems for collecting, validating, and preparing data. They develop and maintain data pipelines. Data scientists use dynamic techniques like machine learning to gain insights about the future. It is important to understand that they may or may not work in silos. For instance, a data analyst might partner up with a data engineer to work on sourcing the data and ingesting it into the system where analysis will take place. And it is not uncommon that these roles are sometimes performed by the same person. Which is why, although the focus of this course is on data analysts, we will cover topics like ingestion and storage, and give a little preview of doing some machine learning in BigQuery. Two of the most common barriers a data analyst will run into are either too much data or data that is not connected together. Three themes are usually common. Querying, where the queries take too long or have very complicated logic. Infrastructure, where you see issues with scalability, maintenance, etc. Storage, where capacity may be a concern, or pricing could be an issue, or maybe not all data is centralized. Again, it is imperative to note that data engineers and data scientists also face similar challenges when it comes to storage, infrastructure, and working with the data. Well, the good news is Google Cloud can help you with storage and infrastructure. It has also been designed with scalability in mind, an actual global elastic cloud, so that you can focus on query writing and data analysis to unlock those insights even faster. We will discuss that briefly in the rest of this lesson as we compare on-premises servers and infrastructure with Google Cloud. Let's start with storage. In December 1981, the cost of a 10-megabyte hard drive was $300,000. In 2023, a 1 terabyte hard drive is less than $20. Storage has become so much cheaper. Although hard drives are cheap, they're not the only thing you need to have to query big data. You will also need computing power, networking, admin, and hardware teams to maintain and upgrade your infrastructure. And not to mention software and software license costs. But even after managing all that, how do you find the needle in the haystack of data? Traditional databases are not up to the challenge of data of this scale. If you look at most big data projects and really look at where time and money is being spent, you see that most of the time isn't spent getting insights from the data. It's spent on the care and feeding of the machinery, managing infrastructure, manipulating data, monitoring, and performance. Whereas what you really want to spend your time on is data analysis. We realized this ourselves at Google several years ago, and so we started developing systems that 1. Scale with your data growth even as it explodes. 2. Are managed so that you aren't wasting time on dealing with all of the underlying complexities. And 3. Are just generally magically awesome so you can get back to data insights and not data management. The message we are trying to convey is, don't build it yourself when you can leverage Google's massive infrastructure. And speaking of infrastructure, here is a map of Google Cloud's network infrastructure. The number of regions and zones is continually increasing. An up-to-date view can be found at cloud.google.com/about/locations. The network and points of presence are available in the Network tab at that URL. The edge points of presence are the locations where Google networks are connected with internet service providers to allow users to connect. The Google Cloud Network strongly distinguishes Google from other cloud service providers. The points of presence allow Google to provide very low latency network performance. The other big benefit is, of course, scalability. If you manage your own infrastructure, you still pay for power for unused CPUs on premises, especially if you have storage disks and CPUs on the same servers. But with cloud, you can use the same processing power as having 120 machines to process 1 terabyte in 1 second, just as if you had one machine process the query in 120 seconds. And the scaling up and down is automatic, so there is no guesswork for demand. If you need more, the cloud scales up elastically and then goes away when not in use. One of the key features of Google Cloud is the decoupling of storage and compute power. With an on-premises setup, typically both storage and compute are co-located right on that server, which means that you pay for the ability to use processing power even when processing is not happening. With Google Cloud, the separation of compute and storage ensures that you pay only for the resources you use. So if you are only using storage space, well, that's what you get billed on. BigQuery combines all these great features that we just discussed and powerful analytic tools to help data analysts focus on data instead of resource management. BigQuery is Google Cloud's fully managed enterprise data warehouse that helps you manage and analyze your data. BigQuery's serverless architecture lets you use SQL queries to answer your organization's biggest questions with zero infrastructure management. BigQuery's scalable, distributed analysis engine lets you query terabytes in seconds and petabytes in minutes. BigQuery maximizes flexibility by separating the compute engine that analyzes your data from your storage choices.